Sustainable Building Materials and Practices, sponsored by APJ Abdul Kalam Technological University. For this session, we have got a prominent speaker, Dr. T.I. Eldho, professor in the Department of Civil Engineering, IIT Bombay. He was a water resource planner and modeler at Mott MacDonald International, Cambridge, UK, Senior Research Fellow at Hydrotech Research Institute, National Taiwan University, Taipei, and also worked as assistant professor in IIT Kharagpur, India. He obtained his BTech degree in civil engineering from Mar Athanasius College of Engineering, Kodamangalam, MTech and PhD from IIT Bombay, and postdoctoral fellowship from Institute for Hydromechanics, Germany. Research interests includes groundwater flow and pollution investigation, computational fluid dynamics, coastal hydrodynamics, watershed management, application of numerical methods in water and environment. He had 7 sponsored research projects completed abroad and 14 sponsored research projects within India. He has done around 35 major industrial research projects and 45 other consultancy projects since 2016. Dr. T.I. Eldho has published more than 140 journal papers, 8 book chapters, and submitted 2 patents. He has served as editor for many international journals and is the life member of various professional bodies like Institution of Engineers India, Indian Waterworks Association, Fluid Mechanics, and Fluid Power Society India, Indian Society for Hydraulics, and Society for Technical Education. With this brief introduction, I would like to invite Dr. T.I. Eldho to deliver the talk on the topic, Sustainable Water Management through Wastewater Recycling and Conservation. Sir, please.
Okay. This slide is visible, am I right?
Yes, sir, it is visible. Can you make it full screen?
Yeah. All right. Okay. Okay, so thank you very much, Professor Ammu, for introduction, for the nice introduction. So the audio, video, everything is fine, am I right?
Yes, sir. Yes, sir. Yes, sir.
Okay, so welcome all participants, the college teachers, and all my beloved friends in Kerala. So actually, I am also from Kodamangalam only. So currently located at Mumbai in IIT Bombay for the last 20 years. So also I visited many colleges in Kerala, including MA College of Engineering, then Cochin, this Model Engineering College, then Adur Engineering College. So all those places I am either BOG chairman or member, so that way a lot of connection with all the engineering colleges in Kerala. So that way I'm very happy to see that MBITS, actually MBITS is my place only. Actually I belong to that church only, so that way I can say my college. So I am very happy to see that MBITS is organizing this program, and civil department is doing very well in MBITS. So I am also now a BOG member of MBITS, so that way I am very happy to address the gathering. Anyway, so in this the faculty development program, which will become which has started today and going on for next 2 days. Actually, the topic is sustainable building materials and practices. So earlier I told organizers how I fit here, but anyway, then they told that there's a topic of environmental sustainability. So that way, I hope that humankind or nothing can survive without water. So I thought, okay, I will give a general lecture on water management within the perspective of sustainability, and especially environmental sustainability, which is one of the topic listed for this program. So I hope all of you have very nice lectures in the morning, 2 sessions, and then it will be especially related to building materials, sustainable building materials will be continuing. Of course, as I mentioned, without water you cannot survive, and then of course for all kinds of sustainable material, water is an important component. So that way, water sustainability is also very important, or environmental sustainability is also very important. So the topic which is I am going to discuss today is slightly different from whatever you expected maybe with respect to the sustainable building material. So please bear with me. So since within the environment sustainability, we will be general. It will be a general topic, general discussion only. This lecture will be next 1 hour will be 1 hour or 1 hour 15 minutes will be in the context of general aspect with respect to water management, especially within the perspective of environmental sustainability. So that way, and now we are going to discuss many aspects, including wastewater treatment, water resource management, and planning, and especially in a small community like especially places like Kerala, which is having so many problems of wastewater management. Of course, Kerala, the God's own country, is very much blessed with a lot of rain and a lot of water. But the other face of that is that, as we already see in 2018, the flooding and other kind of issue. But anyway, we are actually, when we compare with the water management, though we have a lot of sufficient water, no issue. But wastewater treatment and then its utilization or is concerned, we are very much lagging behind. Since you can see that, as all of you know, that Kerala is just like an urban hamlet in, you can say most of the areas are like peri-urban, and we are having 3-4 major cities like Cochin, Trivandrum, and Calicut, and remaining all are so they either some large towns or small towns or peri-urban areas. So within that perspective, we are going to discuss first some discussion on sustainable water management, what is sustainable water management, and what are its water management scenario, what is the perspective behind this, why we have to worry about it, and what is the future about it. And now you can see that now Government of India, they are also pushing for water conservation, rainwater harvesting in a large scale. So though some of you are only working in structural or the building area, this area is also very important, and number of projects or number of things are happening. So we'll be discussing about water conservation. And then, as I mentioned, wastewater management, especially in urban areas, in flats, and then in all buildings or even individual houses, it has become a big problem. So wastewater scenario, we'll briefly discuss what is happening in India. And then, so what are the major systems, wastewater disposal systems, Indian situations and standards, and then we'll discuss in terms of preventive environment management, since sustainable environmental issues are major issues when we discuss all aspects as per within the perspective of town planning or building management or all the civil engineering sectors are concerned. And then also we'll be discussing sustainable natural treatment systems, and then one or two case studies. One is from IIT Bombay, and another one city will be discussing, say, within the perspective of what we are discussing today. So as I mentioned, the sustainable environment management is a major topic. So whenever we look into the issue of sustainable development, so we will be looking all aspects in a holistic way. We need to look into the environment. So the environment, you can see that the total system which we are dealing in a common way. So we see that it can be the atmosphere, it can be the water, it can be air, it can be soil, it can be all the aspects will come. So environment, as far as we are concerned. And then, of course, now you see that the last few years, few decades, we are having in a very, very haphazard type of developments are taking place. So within that aspect, so though the economy is booming up, so you can see that we can say one way or another way, due to this, without appropriate environmental management, that is even the COVID problem or coronavirus problem also we can relate to the environmental issues, since we were neglecting the environmental issues. So that way, if you want to sustain, if you want the sustainable development or sustainable development and management, or especially within the perspective of water management, we need to see when we talk about high level development. So the Government of India wants to put a 5 trillion economy, all those things we are talking, but we need to see everything. Though we can go in a slow mode, doesn't matter. but we need to see the sustainability, the environment we need to protect, and then within that perspective, the economics will come, and then whatever we are doing, whatever as a humanity, what we are doing as a society, what we are doing as culture, what we are doing, so everything will be coming. So these three circles we can put it, and then whenever it is coming together, we can say that the economy is taken care, the society is taken care, the environment is taken care. So that way we can say whatever the development is taking place is sustainable. So now within the, since being a water engineer and environmental engineer, when I talk about within the this sustainability, so we need to see that whenever we look into water, you see that water is concerned, which is the most important resource, and without water nobody can survive. So that way the water is concerned, we are having surface water and groundwater, and then you see that there is a lot of issue whenever we discuss about the water. So we need to see that how we can conjecture, I mean both together, how we can use it for multiple usage, like it can be domestic, it can be industrial, it can be agriculture. So in a country like India, where almost 80% water is used for agriculture, we can see that how to make it sustainable, since whatever was available, say for example 1950 and 2050, if you consider, even say if it is more than 2050 meter cube per capita per year was available in India, and now by 2050 it will be hardly less than 1,000 meter cube per capita say per year. So that will be the situation. So almost it will be very, very small when you compare with the developed countries or other countries are concerned. So that way we need to see the water conservation, and then use of say how we can use the wastewater, since we are making so much of wastewater. So almost when you say that the water supply is coming from municipal corporations, with whatever is supplied, whatever with respect to usage, almost 90% is going back as the wastewater. So within that perspective, we need to see what way we can have sustainable development and management, especially in the water sector. So why we need a sustainable water management? So you see that the same water that existed on Earth billions of years ago, that is still exists today, and then it is coming through a cyclic way. So that way we can see that when we look into what water is available, so almost hardly, so though so much water is available, hardly less than 1% of fresh water is readily accessible for our purpose, our use. And this out of available 1%, even you can see that almost 99%. Say here what is there is almost most of the water is in the groundwater, and that also we cannot utilize. So that way what is available is hardly available fresh water, only 1% is utilizable, and 99% is in groundwater and remaining in surface water. So within this perspective, we need to look into how we can effectively utilize what is available, how we can in an integrated way what we can use it within the water conservation, sustainable water management is concerned. So that way, when we look into, it is very important to look into the sustainable water management. So since it is the most precious resource, so the water scarcity is there everywhere, and then even in places like Kerala, where say we are having almost 7-8 months of including the upcoming monsoon and retreating monsoons. So both the southwest and northeast monsoons, we are blessed with these two monsoons. Still, we are, say, whenever the rain is not there for hardly 3 or 4 months, we are having a drought kind of situation. So that way, when we look into whatever the United Nations have put to the global challenges, out of 15 global challenges facing, it is second position is there for the clean water, and of course first one is again related to water and hydrology only. It is mainly with respect to climate change. So that way we need to look into it, is so important, and then we need to see that whatever we are using, the water we are using, how we can say use it for future in a sustainable way. So here, if you look into the projected global water scarcity, you can see that the physical water scarcity, which is put in this red, you can see that in India, many areas are under this red zone, and then we will be having very severe problem in later. And then, of course, economic water scarcity means water resource abundant relative to water use, but with less than 25% water from rivers withdrawn, and then it is related water-related stress is there. So that is what is the condition. So some part is, say, severe stress, physical water scarcity. Some part we are having the approaching water scarcity, physical water scarcity, and some part we are having economic water scarcity. So in India is concerned, we do not have, other than some northeast small states, we do not have a place where there is no water scarcity will be there. So that way, within this perspective, we need to look into developing intelligent water resource management system necessary to remedy this problem. So that way, we need to look into various aspects. So now, within this perspective, when we look into the current water management systems, so you see that especially, as I mentioned, Kerala is concerned, we can see most of the towns are just like peri-urban areas. So where, say, other than 3-4 major cities, so that way, whatever even small towns, you can see that it is congested infrastructure. That is very clear whenever the 2018 flooding happened. And then you can see that even the water supply, what is done, so there is a lot of leaks and theft, and then there is no automated systems are available. So that way, no sensoring or sensors are put, and these are all some of the major areas, lot of development to be taken place. And then you see that even whatever is available, hidden water network, which is where is it, what are all those things are not. So to remedy these problems, implement fully integrated system. So that is what we need to look into. So now we are all very highly capable of using the artificial intelligence tools. So how we can fully integrate which the system, especially water sector is concerned, which allow monitoring, analyzing, controlling, and optimizing all aspects of water flows, including the wastewater treatment and then its usage. So that is all those things we need to look into in a holistic way. So now coming to this, we need to look into smarter water management systems. So this we call it as, say, when we use now all these the various machine intelligence, machine learning, all those things can be put together. So including sensors, smart pipes, smart meters, and then we can connect to a cloud, and then through internet or through the system we can monitor, we can control, and then we can see. So that is the way generally, say for example, since I am from Bombay, we are taking water from almost 100 kilometers away from the city, and then all these things by sitting in one office through a completely automated systems, we can observe, we can control, we can do everything. So that way, so within this smarter water management system, we need to look into the data collection, data dissemination, data integration, modeling and analysis, analytics, and then visualization, and then which will lead to finally the decision support system. So that way, we need to look into in a holistic way as far as smarter water management system is concerned. So when we look into the smarter management system, so strategic water management system, we need to, as I mentioned, we can use now, we are having the machine learning techniques, then artificial intelligence, all those things we can connect through by monitoring, integrating the information from say not only the water supply system, but even sewer systems, all those things can be integrated and collect and analyze the information from metering in a water metering in a real time. So if you see that this is your urban hamlet which you are dealing, whenever you are doing town planning or the urban planning, so we can connect together all those things in a very efficient way, and then we can put into using the machine learning techniques based on water management, detect anomalies, analyze trends, then understand behavioral models and provide usage and predictions and input too, so that we can optimize and then we can have better control. So if this is a particular city, and then if you are having the water supply connecting network like this, so everything can be put to through the sensor systems, and then finally we can control from the control room whatever the way we are doing this as we call it a strategic water management system. So now coming back to, if you take holistically as far as India is concerned, as I mentioned, India is very much stressed with the lack of water, and then so we have already seen our earlier map showing this the water distress, and then some areas, one third of the area is going to be distress in few years time, and only one third or less than that will be there sufficient water in future. So India sustained, the problem is that India sustains 17% of the world population and just 4% of the global water resource. And then out of 50% of annual precipitation received, just all this thing happens in few days time. So this is a major challenge as far as water management is concerned. So that way we are having limited storage of 36% of utilizable resources. And then even in the most of the cities we are having, so the water supply through pipe, what is happening there also, even more than 25% leakage and inefficiencies are there. So that way we need to look into as far as water supply or water management is concerned. And then you see that in many areas, so as I mentioned, when you say the integrated use of surface water and groundwater is overexploited many areas like Punjab, Haryana, Delhi, etc. And there the water level is going drastically down. So over 70% surface water, groundwater resources are. So another issue is that main issue is the contamination. So water quality is a major issue, because even though so much water is available, if it is not to the level, the quality whatever is needed, so that way then it will be very, very difficult process. So now if you look into this way, there will be a huge gap will be there with respect to what is available, say water supply gap is concerned. You can see water supply and demand. So here now itself 2020 or 25, there is almost 12,000 gap. And then this will be by 2050, it will be, it is estimated that it will be more than 30% or about 25 to 30% water supply scarcity will be there. So even domestic supply or even industrial supply is concerned. Since most of the water what is happening is that we are using for irrigation, so almost 80% or 75 to 80% water is used for irrigation. So that way, if you consider the river basin in India, water shortage is concerned, you can see that severe shortage. So most of the almost 80% of the country will be by 2030 or even later stage, it will be severe shortage is what we are estimated. Including some part of Kerala, you can see here, though we are blessed with so much of rain within the say the southwest and northeast monsoon. So that way, now when we look into a holistic way, the issue, as we can see, that this is the spatial temporal variation. So the whatever, say for example, in places like Kerala, it is around 2,500 millimeter rainfall, annual rainfall is there. But then if you look into Rajasthan, where hardly 10% of that, even say 25 centimeter or even 20 centimeter, 200 millimeter rain is there. So that much spatial variation is there. So that is one aspect. And then another aspect is temporal variation. So this is another thing. Say, though a place like Kerala is very much blessed for with almost 7 to 8 months, even nowadays, very much summer rainfall. So, but many other, most of the other part of the country, so you can see that hardly they get 3 or 4 months of rain, and that happens in 15 to 20 events. So that is with respect to space and time variation is a major issue. So that is why we need to look for water conservation, and then that is very, very important. So surface water conservation is most efficient and effective way. So how we can have small dams like check dams, or even in your own land, how we can have the rainwater harvesting, and then we can allow like water banks. So whenever we allow the water to say infiltrate down, and then we are taking it back whenever we need. So that is, we call it as water bank. So within the perspective of rainwater harvesting. So there is a number of conservation methods are available. So you can see that even say here in a household purpose is concerned, you can see that we can directly connect through the systems, and then directly you can take it, and then we can infiltrate back to your own land, and then we can take it as groundwater, or we can store it in tanks, and then we can go for direct rainwater harvesting and utilization. And then we can also the aquifer recharge. So as I mentioned, we can also take this water after some filtration or some post treatment. We can directly filtrate to the aquifer systems, which we can directly utilize. And then you see that here, say we can use these wetlands and other natural treatment system, which we will be discussing later. So wastewater is concerned what is coming from building. So nowadays, you see that say whatever is producing, since if there is not connected to a centralized systems, say in a place like Kodamangalam or small towns where there is no sewage treatment plant or sewage directly, you can see that the best way is that all this can be connected. It can be go for further some filtration, and then so you can put after some treatment, it can be say for that water can be used for irrigation, and then we can say put the remaining water to the water bodies. So that kind of conservation methods we need to look into. So now when you talk about sustainable water management by water conservation, this figure shows what is possible. As I mentioned, it is starting with the harvest rainwater from roof, and then so of course we can also think about some of the, since we are talking about building materials, building sustainability. So when we say that, now all of you know that the green buildings concept now. So whatever you are designing, whatever you are planning within the perspective of green building, so whatever we suspected is that self-sufficiency. So that way we have to see that whatever is say especially rainwater harvesting, integral part of that, and then a small say wastewater treatment or solid waste management is also part of this green building concept. So that way we need to plan accordingly. And then say for example, if rainwater harvesting, if it can be directly harvested, and then it can be stored and then directly utilize it, or it can be also as I mentioned, it can be recharged. And then the wastewater is concerned, it can be collected, and then also especially the water coming from the bathrooms and then the kitchen, this water can be gone through some treatments, some basic filtration and other kinds of simple treatment, and that can directly used for your gardening, your car washing, and all those kind of things. So that way, within the green building concept, we need to look into all this in a holistic way. So that is what is the need of the hour. So that is why when we say the sustainable building materials, so that way it is not only just a brick, mortar, and then the cement, all those things, but we need to look into the all other aspects also in a holistic way. So that is why, as I mentioned, though I'm not talking about the building materials and the building construction, we are looking the other aspect of the say water management and the wastewater management. So within, say, when you're going for a construction of a building, or when you're going to construct a town or an urban hamlet is concerned. So that way, sustainable water management is very important. So it is not only the freshwater resources, but the wastewater management is also concerned. So now coming back to what is happening in developing countries, so you can see that as you can see, even though say we call the Kerala the God's own land, so we are having so much of water, but whenever there is no rainfall for 3-4 months, all of our wells become dry, and then we look for the water supply. So, but you can see that though in many towns and a lot of water supply schemes have been developed, so it is totally inadequate. So when you consider in a holistic for the total state is concerned. So that way, and now also, no, it is not only that whatever the water supply is, whether sufficient, the quality, how is that quality. So increasing demand for domestic agriculture as well as industrial purpose. So we need to have more water resources, and then so we need to see its quality. So when we look into water quality, some of the important aspects you can see, like a discharge of partially treated, untreated wastewater effluent into the water reservoirs. So if you look into the most of the rivers in Kerala, so you can see that, say for example, 30 years or 40 years back, this water we can directly, river water we can take in hand and directly drink. But currently, if you look into, say, those who are from Kodamangalam, if you look into Kodamangalam river, you can see that even we are afraid to say swim in the river. So that kind of situation has happened. So that way we need to see that what are the causes, like discharge of partially treated or untreated wastewater. So in places like Kerala I can say that only wastewater treatment plants are only there, maybe in Cochin, Trivandrum, and maybe Calicut, few cities, and remaining all these places simply without any treatment, people are putting the wastewater to the rivers and streams. So then, of course, agriculture and urban runoff. So you can see that we are using a lot of manures, a lot of fertilizers, a lot of herbicides for agriculture purpose. So all those things what we are putting, only hardly few percentage is absorbed by the plants, and remaining all go to the either surface water or groundwater. And then, of course, as I mentioned, whenever our lifestyle changes, we need more water. So now, say for example, the average water supply what is put forward by CPHO is 135 liters per capita per day, but we are looking for about 270 or 200. So that increasing water demand. And then, of course, excessive water withdrawal prevents dilution of pollutants. So that is also, especially rivers are concerned. So that way, when you look into this, so the surface water pollution is a major issue. It can be from the industry, it can be from the household, domestic, or it can be from the environment itself, like acid rains, or it can be what is happening with respect to the pesticides, fertilizers which you are using. All these can say pollute the surface water like rivers, lakes, and all those things. And then even say most of the household, especially in places like Kerala, we are having say for our own toilet, we are having our septic tank. Most of the septic tanks, there can be some leakage that also will be polluting the surface water and groundwater. So now coming back to the other source, so most of us are dependent upon the groundwater for drinking purpose. So the groundwater contamination is a major problem. So groundwater contamination can be coming from landfill, it can be coming from surface runoff, or say the septic tank which you are having your own household septic tank, so that it can leak, and then it can pollute the aquifer system or the groundwater system. So that way, the surface water pollution or surface water contamination and groundwater contamination is a major challenge, and we need to look into in terms of when we say that sustainable water management, sustainable environment management, we need to look in a holistic way. So that way, sustainable water management includes reclamation of wastewaters for recycle and reuse. So that way, we always propagate the theorem of triple R, say like recycle, reuse, and reduce the usage. So these are the three important concepts, like reduce, recycle, and reuse. So that way, whatever is, though of course people may ask when the next rainfall comes, everything will be, no, it is not like that. So if especially pollution takes place, if we are not treating it properly, and then it is again going to say have a very serious health impacts later, or very serious issues. So the treated effluent can be used as a water resource for beneficial purpose. So that is what is the major concept I would like to discuss through on our case study. So the effluent is kept out of streams, lakes, and beaches. So that way it will reduce the pollution of natural water reservoirs. So you can see that if you, since so most of our cities are on the banks of the river. So one city, upstream city, so the water is taken, and then wastewater is putting back to the river. And then the next city, when it is coming, you see that all this waste is again going to, and then if they want to have a water supply. So for example, if this is your river, and then if you are having a city here, and the city here, and the city here, so like that, so the water is taken, and now the wastewater is coming back. So if it is not treated properly, you can see that this next city will be affected. So that way, we need to look into in a holistic way when we talk about sustainable environmental problems or environment management or water management is concerned. So that way, so here you can see that in an urban hamlet, so whatever either the sewage is coming, so if it is not treated, so the major problem what is facing in Kerala, place like Kerala, is that wastewater is not treated. But we need to, so whatever if you look into, many of you are either teaching environmental subject or you already learned this, so that is nothing new here what I am talking. But I want to sensitize whatever the major issue here, and then we need to go for more research, more locally oriented solutions we need to look forward. So now, say for example, a city like this, the sewage system is there, then we can have the preliminary treatment, say like primary sedimentation, all those things, and then we can go for the secondary treatment. So here, so the whatever is coming, the secondary treatment. So maybe if it is to the limit, the way we have achieved the environmental standards, then that can be directly used, or even after the tertiary treatments, like including the disinfection, all those things. So there we can use the say it can be with respect to filtration, it can be disinfection, all those things can be done, and then it can be used for like irrigation, or even it can be used for many other purposes, gardening and all those aspects. So that is what is the way we need to look into whenever the wastewater system is concerned. So now, say if you look into, so it is not only place like Kerala, the whole India is concerned. This wastewater treatment is very, very low, even hardly 20 to 30% or lower than that. So that way, it has become a major challenge. So due to agriculture growth, industrialization, urbanization, wastewater generation increased drastically. So for example, almost 40,000 milliliters per day sewage is generated in major cities of India, but the sewage treatment capacity is hardly less than 30%. And then, and similarly, the industries are also concerned. Almost 60% of the industrial wastewater treatment is only, say that treatment also not to the level what is needed, and then it is simply discharged to the nearby water bodies. So that way, we are facing a thin-edged problem to deal with the reduced freshwater availability. So that is why I'm now connecting the freshwater and the wastewater, and then increased wastewater generation in coming decades. So already this is happening. So now the discharge of untreated sewage into water bodies has resulted in a contamination. So that is what is a major issue we look into now. If you take the case of Ganga river regeneration, you can see that though government of India spent thousands of crores almost last 2 decades, so you see that still almost hardly 20 to 25% is not achieved. And still, if you go through the main cities like Varanasi, including where Prime Minister Modi's the parliament constituency, there also, if you visit those place, it is the water even we cannot say just take that water in hand. So that is the way it is still polluted. So that way we need to take into in a holistic way. And as I mentioned, Kerala is blessed with almost 52 medium and small rivers. So all these rivers, you can see now, we are doing a major project for the Kerala, under the government of India, climate change and its impact. So that we are, when you look into this, all these river basins, it is very much polluted, and then it has a major issue of the water quality issue. So that way, say for example, total India is concerned, the wastewater production in India. So as I mentioned, almost 40,000 MLD, and out of that, hardly say 12,000 MLD is only treated. So for 498 class 1 cities, and then another class 2 cities, you can see it is hardly less than 10% treatment is done. So that way, so maybe if we look into Kerala, that will be coming in this category. So performance state-owned sewage treatment plants for treating wastewater is not complying with the prescribed standard, though even though wherever the treatment plants are there, it is not to the level the treatment is done. So thus making effluent from these plants often not suitable for household purpose, and reuse for the wastewater is mostly restricted to agriculture and industrial purpose. So that is the major challenge when we look into various aspects of wastewater production and then treatment is concerned. So this is what I was talking. So the metropolitan cities, say, if you say that it is more than, say, maybe, say, it is, say, hardly 50% or less than that 50%, but class 1 cities, it is hardly 1/3 or less than that, and class 2 cities, it is much more less. So the wastewater treatment scenario as far as the country is concerned. And then, so you see that the wastewater generated with respect to wastewater treated. So this is very similar to the previous. So now, when we look into in a holistic way, sustainability issues, so especially water-related sustainability issues concerns, say we can see that various pictures. This is from Mumbai. Many of the streams, what is happening, even coastal coastal areas also, they're simply damming without appropriate treatment. So the mode of disposal, so you can see that what can happen indirectly into rivers, lakes. So this is what is happening in most of the part of the Kerala, and on the agricultural land in 63 cities directly into rivers, 41 cities, 44 cities, it is discharged both into rivers and agricultural land. So this is some statistics. Many of the coastal cities wastewater find its way into estuaries directly without much treatment. So these are the major challenge as far as the wastewater scenario, and when we talk about sustainable water management or sustainability, sustainable environmental management is concerned. So that way, we need a paradigm shift. So now, the aspect last few 1 or 2 decades, another thing is coming. So we are looking for zero discharge or zero, so that all the wastewater can be directly utilized. So, say for example, this is already practicing. If you visit Singapore, so even though the water we are drinking can be directly coming from your septic tank or even coming from the wastewater. So that level they are going for the treatment. So this is so-called in Singapore new water scheme. So there they have achieved that, since otherwise they were bringing large amount of water from Malaysia, but now they have reduced it and they are going for, so they are not disposing all the wastewater into the sea, but they are directly going for the treatment and then reuse of that water. So another example, one typical example which we can talk about is in Mumbai, Rashtriya Chemical Fertilizers. There, those who have visited, you can see that here, say they are not only treating their own wastewater for their industrial purposes. Rashtriya Chemical Fertilizers means you can see that fertilizers production, so they need so much of water, and then actually now they are buying wastewater from Mumbai Municipal Corporation at various locations, and now say they are going for say around 500 mld. They are treating, and then so directly, so they are actually paying. So that way, municipal corporations also benefited. They are paying for this wastewater, and then they are taking it, and then they are treating, and then that water they are using for, especially for fertilizer production. So that way, we now what is the concept is zero discharge. So that is what is for many industries that is happening. That is a very, very positive change. And then we need to also look into, especially peri-urban areas, like most part of the Kerala is peri-urban area. There we need to look for recycled water for domestic purpose usage, how we can utilize it. So that is where, whenever we say sustainable building, sustainable building construction is concerned or planning is concerned, we need to look into. So we need to treat the wastewater for groundwater recharge and irrigation. So here, some of the major issues, what is to be done to develop tailor-made treatment process for various situations. So this varies from one situation to another situation. So what is applicable for industry is not applicable for domestic water. And then even domestic water also, what are the water coming from kitchen, whatever the water coming from wash basin, that is all different nature. So that is why we need to develop the tailor-made treatment process for various situations. And then we need to look for wastewater treatment, reuse and recycle, how it is possible. And then we need to look for life cycle analysis of wastewater treatment system. So how it is going, and again coming back. So that is why this term called new water scheme, that is what is implemented now in Singapore. And then, as I mentioned, a few of the Indian industries are also doing this. So that is we call it as paradigm shift. And whenever you say that a theoretical zero discharge means, so there is no emissions. So say if you take whatever is there, liquid, solid, liquid gas, so the production plant is concerned. So directly we are producing whatever is there in terms of solid, liquid gas, and then whatever is the value. So whatever the periphery like wastewater or the solid waste, whatever is coming, that we are putting as a value-added product. So that is what is the concept called zero discharge. So that is what now many industries are doing that, and that we need to propagate. And then of course local, as I mentioned, those who are hearing me, so you are all college teachers, I understand, so that you need to look into further kind of innovative say research you need to do, local scale, how this can be done, local, say for your small towns or small cities, how this thing can be achieved, so or even housing colonies, how it can be achieved. So that way, the first one is zero discharge and then zero liquid discharge. So that is of course with respect to water. How without any wastewater should not go from our premises, but that can be, it has to be used for different purpose, and different products can be, or different usage can be done. So that way, when we look holistically in terms of sustainable environment management, sustainability issues are concerned, so you see that very easy solution is, usually favorite solution is to simply put some treatment for say sewage and wastewater, and then you can dispose them to receiving water bodies like simple the river system or the estuary or to the sea. But the other way, which is very difficult to achieve, is you can see here, the other less favored solution is to treat the sewage and wastewater to high standards and then reuse, recycle. So again, I am telling 3 R's: reduce, recycle, reuse, and recycle. So that should be our motto, and that is, it is not so easy to achieve, to go to this level. It is a lot of difficulty, lot of course, money is, cost is also involved. So that way we need to look into. So that way, as I mentioned, wastewater, since when you talk about sustainable water management, sustainable environmental management, wastewater is a major aspect. Of course, in Kerala, solid waste management is also a big problem. But now we are discussing in terms of wastewater. So wastewater treatment options are there. Many treatments options you can see from various literature, like it can be physical process like simple screening, sedimentation, flotation, filtration, etc. And chemical process we can, which is expensive, like coagulation, absorption, oxidation reduction, etc. And then biological treatment like aerobic treatment, anaerobic treatment. So these are the processes. And then treatments are concerned, it can be preliminary treatment, then secondary treatment, and tertiary treatment. So when you talk about primary treatment options are concerned, and we can have screen traps, grid chambers, septic tanks, sedimentation tanks, etc. So that is that include all these primary treatment options are concerned. And then we are having number of treatment plants. Now you see that in city where Mumbai city is concerned, I'm also a committee member where we are evaluating. So as I mentioned, Mumbai is concerned hardly 30 to 40% wastewater treated, and that also not to the level it is to be. And now they are planning in a huge level. They are now planning for a 6-7 large wastewater treatment plants. They are now in the process of making, and construction is they are going to start very soon, so that from 40% whether they can achieve to 70 or 80% wastewater treatment. So there, other than the primary treatments, say if we are not going to use the water directly, and then primary treatments, and then many times we put that wastewater into rivers or estuaries, all those things. But if you are going to use that water to certain level, then secondary treatment is essential, which is quite expensive. So like through activated sub process, trickling filters, waste stabilization, pond, aerobic like lagoons. So there are so many schemes, like very like a sequencing batch reactor is very much used nowadays, which is coming as industrial unit way. And then latest like membrane bioreactors or moving bed bioreactors. So these are all the latest technologies which give high quality say water after coming this thing. And then if you do one more tertiary treatment, even that water can be used for many including the domestic purpose. So these are some of the secondary treatment options. And then comes the tertiary treatment. So tertiary treatment like in disinfection, and then again going through micro or nano filtration membranes. So that is what is the Singapore government is doing. So that water can be directly utilized for, so that will be very pure water. So that tertiary water treatment options are there if you want to reuse to a large scale. So, but that is again quite expensive. So based on the cost benefit or cost effectiveness and requirement system of wastewater treatment can be chosen. But as I mentioned, in place like Kerala, where many towns, small towns are there. So there, at least if we can go for primary treatment and some of the secondary treatment, that will be very useful. So that way, one of the naturalized system which is called constructive wetlands. So that is what we'll be discussing later stage. So that has been found to be very attractive options. So now when you look into, say, wastewater treatment is concerned, what is appropriate? So we want a low cost with minimum possible mechanization. So that is one answer. And then see, it should be many times what happens is that though in 1990s and 2000 afterwards, many state governments initiated the central effluent treatment plant, CETP concept, but there the operation difficulty. So whatever we are choosing, it should be simple in operation and then suitable for incremental improvement. So whatever is coming from one system to another, and then finally we should be able to use recycle and reuse oriented system. So that is when we say what treatment system is more appropriate. So now when we look into for a small cities or small towns, so what are the design principles? So as far as the Indian standards are concerned, designs sewer networks, major parameters to be considered: population to be served, population density, water consumption, etc. And 90% per capita water supply is assumed to be entering to sewage system, as I already mentioned. So based on these needs, physical conditions, available resources, so we need to look into how the sewage system is to be planned, whether it is separate sewer system or combined system or pressurized system or solid free system. So like that, various options we need to look into. And then so depending upon the water supply, say the city is concerned, we need to look into what kind of standards we will be able to achieve through treatment. So you see that whatever kind of process we are taking, we are talking about primary treatment, second treatment, etc. So whenever the solid say the suspended solids or BOD or total coliform, what level we can achieve through the treatment. So that is a very important parameter which we can consider in this kind of say when we talk about sustainable wastewater treatment or water treatment is concerned. So if you are looking for treated sewage usage as a drinking water, then we need to go very level. So you can see that of course, as I mentioned, the new water scheme in Singapore, wherever the water is put into for drinking level, so there all BOD should be less than 10, the suspended solid should be less than 10, all nitrogen should be less than 10, dissolved the phosphorus, all those things should be. So all those we can achieve, of course, but that will be expensive. That is the major challenge. But when we talk about sustainable environmental issues, sustainable management is concerned, if we can go to that level, that will be very fine. But maybe at least, as I mentioned, most of the Kerala towns or this needs at least the primary and secondary treatment as far as the wastewater system is concerned. Otherwise, we are now polluting all our water bodies, including rivers and lakes and ponds, as far as in a place like Kerala is concerned. So now this is actually a part of the water cycle itself. So you can see that water resource, starting from rainwater retention basin, then so we need to go for purification, and then water supply distribution. Then further comes the water usage for various purposes, whether it is domestic, industrial, or agriculture. Then comes the wastewater. So wastewater treatment, various schemes we have already seen, and how we can put the appropriate system for the given area is concerned, given the even household or even the building complex are concerned. What kind of possibilities are there? We need to study in detail and then come for the appropriate management of the wastewater system. So within this we have to talk about a term called preventive environment management. We could use a term called preventive environmental management. So that is to achieve the environmental sustainability. So here we are applying continuous application of integrated preventive environment strategy to reduce risk to humans and environment. So that is, you see that if you don't go for this, so finally now we are all scared about COVID kind of situation. So that kind of situations are going to recur many times, and that is going to have a big problem, whatever the development we achieve. So that way, conservation of energy and raw materials in the production process is also important. Reduction of toxicity and quantity of all emissions and waste leaving from the production process is, say, especially industry is concerned, and then reduction of impacts along the entire life cycle. So we need to look in that way. So the preventive environment management tools are concerned when you talk about the either water resource management, sustainable water resource management, sustainable environment management is concerned. Some of the important aspect is preventive environmental management tools are the environmental audit. So we need to see that in a housing colony or in a city or in a particular industrial plant, the environmental audit is very essential. And what is the environmental impact assessment is important. So whatever the wastewater we are putting, how it is affecting the environment. And then especially in an industry life cycle assessment is important. And then inventorization, what is happening within that industry, and then finally it will lead to EMS or environmental, we call it as environmental management system. So that way, to have an appropriate EMS, environment management system, we need to identify what are the potential interventions are possible, and whether, as I mentioned, like green building, greener chemistry and greener processes, how we can implement, and then whatever the technologies we are using, whether we can go for more greener technologies, and what are the green choices. So this is also, it is very true as far as building construction, building management, and also the construction industry is concerned, the green choices. So that is what we need to look into. And then based upon that, what is available, what is possible, redesigning the unit operations and unit process, that is the need of our within the perspective of preventive environmental management interventions are concerned. And then, as I mentioned, so we need to even building materials, building whatever we are doing. So we need to reduce whatever is the minimum utilization. Then wherever possible, we need to recycle and reuse. So that is very, very important. And then that way we can go for a sustainable and intelligent consumption, intelligent pattern, and that way that will be extended producer responsibility, and finally it will be leading to eco-industrial network, and integrated policy making is possible through the preventive environmental management is concerned. And now as far as the latest thinking, latest rules are concerned, the polluter should pay. So that is either an industry is polluting this thing, so a large scale is to be introduced, and so that is the basic principle. So that way now most of the environmental protocols, what is done in 2000 in Kyoto or afterwards in Montreal, everything we are putting in terms of the concept of polluter should pay, and then we are putting the environment or the people first, and then that way we need to look into, and finally so that way only we can achieve the sustainable management of sustainability is possible. So that is what we need to look into, especially the environmental sustainability is concerned. So when you talk about the various strategies for transitioning to sustainable future, so science and technology with innovation, so that is now everywhere that is happening. So many new techniques for either wastewater or solid waste management is concerned, it is coming. And then whatever the system is concerned, we cannot have very complex systems. So that is so now an engineering branch called frugal engineering is all developed, and then there the purpose is reducing the cost and complexity, so that we can have very environmental friendly or very sustainable kind of system. And then, as I mentioned, we look forward for preventive environmental management, and then this development should not be in a vertical scale but in incremental development. That is the best policy. So that way, coming back to, as I mentioned, especially small cities or peri-urban areas concerned, especially wastewater management, which is the main topic of this discussion. So we need to see what are the strategies, especially urban and peri-urban communities are concerned. So here, say one of the technique which we can utilize is the constructed wetlands. So here, this is actually, as I mentioned, this is in IIT Bombay also, lot of work is going on in this aspect. So here, this is starting from raw effluent and from urban or peri-urban communities concerned. So initially, some primary treatment will be done, and then, if possible, we can go for some secondary treatment also. And then it will be this water. What is coming from that, it can be fed into the constructed wetland beds. So here, CW1, CW2, like that. And then so constructed wetland beds in parallel configuration also possible. And then from there, so of course, this secondary, this treatment is concerned, it can be polishing bond or waste stabilization, and this water can be so either disinfect and then directly utilize, or it can use for irrigation purpose. So this is the this is identified the best sustainable wastewater management system is concerned, especially the small towns or small peri-urban areas are concerned. So that way, so as I mentioned, or another alternative way is that raw effluent from rural community, primary treatment, then directly, instead of doing this secondary kind of treatment that is not essential, especially for peri-urban or rural areas are concerned, rural communities are concerned, in a housing colony or that kind of system is concerned. So we can directly, after simple primary treatment, we can put this water to constructed wetlands. The advantage is that if you are having in a community, peri-urban community, so if you are having a garden or that kind of area is there, so there this unit can be established, and then there the treatment can be put it, and that water can be used for various gardening and other kind of purpose also. So here, so from constructed wetlands, it can be put to some pressure sand filtration or membrane process if it is that is needed. Then treated waste for other industries can be directly utilized. So otherwise, it can be used for say wherever, depending upon the needs. So additional inputs, secondary treatment plant can be put, and then the excess water can be put into the pond or rivers. So depending upon the condition. So that way, this constructed wetland concept has been identified as a natural treatment system, and this is a feasible alternative for sewage treatment. So that is what we come in a state like Kerala. This is what we can propagate, and then we need to look into in small towns, small cities, peri-urban area. This is the best. So here the advantages are low cost with minimum possible mechanization, and this is simple in operation and suitable for incremental improvement. So you can go for one unit to another unit. So that way we can continue, and then it can be recycle and reuse oriented. So that is the advantage. So and then it is compatible quality of treated wastewater is possible. So here, so that is where the significance of constructed wetland. So as I mentioned, they are very simple and in operation and maintenance. They require energy only for pumping, and they are less expensive than alternative mechanized, conventional, and advanced treatment technologies are concerned. They can deliver consistent and high-level treatments for organic and pathogen nutrients. They reduce odors owing to their shallow surface flow and dense plant cover. They help to an extent with respect to minimizing carbon footprint, and excellent in context of minimizing mosquito and flies due to subsurface flows. So that is the advantage of this constructed wetland. So in cities like Nagpur and in Mumbai, anyway, we have started in IIT Bombay, we have started an experimental purpose, and then this can be propagated. So if you visit like places like Seoul and other kinds of many cities, the large scale constructed wetlands, you can see, and even it's a tourist place. So that is the way it is developed. So that is what we need to look, especially places like say the Alapi and other kind of areas where a lot of tourists are coming. So this is what we need to look into. So here I'm just presenting a small case study what is done at IIT Bombay. So conservation of wastewater using constructed wetland. So this was done as a part of some of my colleagues. So here it was done as a natural water treatment system for safe, sustainable water supply in the European project. So the study site is located at IIT campus. So IIT has currently 25,000 people. So, and then a campus area is about 200 hectares. A pilot scale horizontal subsurface flows constructed wetland was commissioned for demonstration and research purpose. So that is what I am presenting here. The objective of the case study is to determine a suitable plant species to be applied in the wetlands, the assessment of performance of the system to explore innovative way to utilize the harvested plant material. So here, this is the concept. So many of you will be knowing this constructed wetland concept. So here we make a bed like this, and then this is soil which we put a soil bed, and then we put plants. Actually, these kinds of plant you can see in Kerala, are many places you can see. This scientific name is Kanna indica plantation. So this is what we are putting, and this is the inlet, and wastewater is put here, and then it will be going through slowly. It will be going, and then there is an outlet here, and then what is happening. So that is what we can see here. So actually, two types of studies were done by this research team. One is the laboratory of constructed wetland reactors used in this study was set up and commissioned at the outset of IIT Bombay campus. So with a controlled reactor kind of where raw sewage settled in equalization wells, and then at the end of this batch process, sewage was then completely. So that was one tray to another tray, that kind of concept. So at that point, the conditional laboratory CW reactors are were planted, and this Kanna indica seedling have the stem length of around 30 centimeter, 40 centimeter has been planted. So that is, then all the plant reactors, including the reactor without plants, were filled with the 24 liters of wastewater. So this is one set of experiments were done in this thing, and then another set is directly putting a big constructed wetland. I mean, around say 30 meter by 10 meter was constructed, and there this was put. So typically, so in these two types of experiments, so typically the raw sewage and concentration after 5 days, it was of 80 to 100, BOD was 80 to 100 milligram per liter, and chemical COD was 180 to 200, and the nitrogen was 15 to 20 milligram per liter. So this is what is one experiment system, one to another, as I mentioned in trace. And this is the new system, which is around say around 30 meter long and then 10 meter wide. So here you can see that the wastewater is put through this pipe, and then it is soil is filled in, and then these plants are, this is what is called I don't remember what is the Malayalam name for this. Is very much available in Kerala. So here this is planted, and then the wastewater is put here, and it will be slowly moving through these, and then finally after whenever it is reaching to the other side, the experimentation were done. The laboratory CW reactors and pilot scale CW is this, and laboratory CW reactors are here. And then here these are some of the especially they use the hostel wastewater, what is coming directly from the hostel, and there the TDS, all those things are mentioned here. This is some of the plants they used for these studies. So here, what is the outcome? So percentage removal of COD, phosphorus, nitrogen, and organic carbons in 72 hours. So 3 hours, once the water cycle, you can see discussion of reactors, controlled reactor without plants. So it was COD removal was 51%, TP removal 60%. But reactors with these plants, so some plants are yellow river and some plants are red flower. So it was much more, 61%. 80% and 56%, and with the other plant red flower, so it was almost 80 to 90%. So that is what you can see, nitrogen and the organic carbon removal is concerned. So that is what is actually you can see here in this. So this is this plant. So that kind of system has been found to be very, very useful, and now in many areas, actually my colleague Professor Shyam Asrekar is working on this, and that is extending to many areas in Maharashtra. So the lessons learned: constructed wetlands are used to treat domestic and industrial wastewater worldwide. The engineered constructed wetlands are not isolated example of traditional system, proving to be the fit in the modern times. However, some of the drivers that proved to be favorable to the traditional system and methods during the STS need to be identified. So what kind of plants, whether locally used plant we can use it, and whether that plant itself can be used for other purpose, whether as a manure to the agriculture or other kinds of purpose, whether that can be that also to be investigated. So a knowledge-based approach should be systematically implemented. So these are all, I mean, we have to think locally, and then how locally we can implement this kind of things. And then say, for example, in a town like Imatpura, Kodamangalam, or even Kottayam, or these areas, how we can implement it, and then how it is very cost is very less, and then how the treated water it can be used for even either irrigation or the gardening or other kinds of purposes. And then how that even these plants can be further, what kind of plants. So these also we need a further investigation, so that it will be very useful. So that was some of the lessons what is to be learned and how it can be implemented. I request all those who are hearing me, those who are especially interested with environmental issues, so please look into these aspects, which can be implemented in many places, like in small cities or towns in Kerala. And then last case study is this is about what has happened, especially sustainable water management issue, especially Bhopal city is concerned. You see that this is a typical example which we have scientifically studied in many aspects. So here, those who have visited Bhopal, you can see that it is endowed with several man-made lakes created through the centuries. And this both wetland of Bhopal comprise upper lake and lower lake. These lakes are immense importance to, since they are linked with the socio-economic and cultural aspects of the city. So the upper lake source piped water. So actually, majority of the water supply is almost 40% of the water supply is coming from this. Actually, in 1980s till 2000 or 2010, these lakes are very, very polluted, and then the water quality was so low. And then with the help of NGOs, with the help of social activities, and the government and the municipal corporation of Bhopal, so they started a scheme of cleaning, and by checking, by doing many interventions in this area. So tremendous population growth of city. So now, as per 2011, the census, the population is 1.8 million or 18 lakh. And then here, subject to both lakes to various environmental problems. So the area of this lake is about 31 square kilometers. So this is the Bhopal city, and this is the upper lake region. So as I mentioned here, this water is used for the water supply, also 40% of the water supply. So, but that was very much environmentally degraded till 2010. And there a lot of intervention has happened, and that is what I want to briefly present here. So some of the action taken include integrated lake conservation program that started in 1995. The basic objective of the project was to improve the water quality as well as to increase the storage capacity of the lake. So here this lake was very much silted. Actually, when I visited by beginning of 2000, it was not at all very bad condition. Now when I went last 2 years back, it was the ecosystem has totally changed. So the project activities include both preventive and curative measures, like increasing the storage capacity, controlling the seepage through earthen dam. There is a small earthen dam also you can see here. So with respect to this, I think here whatever is happening, that with respect to that also. And control of weed through deviating, catchment area treatment, prevention of pollution in the lake through diversion and treatment of sewage, catchment area protection through creation of buffer zone, and solid waste management. All these things were integrated together for this area. So this is what has happened, various interventions like small scale wastewater treatment, solid waste management, then these surrounding areas are reforestation to prevent non-point source pollution. So then here the urban catchment to be provided with the sewer network. All those an integrated the system operation was done for the sustainable development of this lake, and that effect was so that has happened almost 5 to 10 years time, and now it has come to such a level that the various the system has improved drastically, that even the water we can directly take it and bring that level. So lake and its catchment is managed as a composite whole. So this is a holistic approach. What is actually, this is also a good way we especially places like Kuttanad or those Alappuzha region. This we can actually one of my colleague, Professor N.C. Narayanan, is now working on that. Actually, I am also part of that team. How we can create a system, especially in Alapi is concerned, there is a lot of canal system, how we can first remove the weeds and then how we can ecologically regenerate the system. So here it is awareness of raising education, stakeholder participations are very essential. So that is with the community's help only this Bhopal upper lake was regenerated, and lakefront protection is a must. So that is administrative and financial mechanism for expeditious decision making. So the district collectors say 2005 to 2010, that period they did a lot of work, and then continuously. So here whatever is happening, so that the continuity in a place like Kerala, one of the major issues that many schemes are started, but that continuity is not there. And that also is very essential. So finally, to conclude some of the important aspects what we discussed. So you see that the water availability itself is a major issue. There is a water distress is there, and that is going to further expand to say maybe in another 20 years, 30 years time by 2050. Whatever the water available 50 years back was, that will be half of that will be available with us for various purposes. So sustainable water management is a major issue. So this we need to look into in terms of water conservation, water recycling, water reuse. So of course, as I mentioned, 3 R's like reduce, recycle, reuse is a very important aspects. And then we need to see maximum efficiency usage of water. So that is also very important, since many of you may be building designers, building, whenever you talk about green building, or whenever you talk about the building, sustainable building management is concerned, we need to see how we can maximize efficiency, very less usage of water, especially in you see that especially our toilet flushing. So why we need to use 20 liter or even 15 liter water, whether that can be reduced to 5 liter or even 3 liter water, whether we can effectively utilize this flushing. So that kind of innovations, that kind of studies are essential, and the youngsters should come forward to that kind of studies, and then that will be very, very important. So maximum efficiency in usage of water is very important, and then plan a strategic and safe and sustainable reuse of wastewater is very, very important, as I already mentioned. And then there is a need for policy decision. So that is also very important. This encompassing low cost wastewater treatment technologies. As I mentioned, constructive wetland is found to be very, very effective. And so though other systems, of course, are available, but that is quite expensive. And then sustainability is a major question. So now natural water system, that is what, as I mentioned, constructive wetland has been found to be very, very effective. And then for successful implementation of any of the system, essential to take care of. So we need to see the social aspects, institutional, administrative, financial, environment, and technical challenges are there. So that is what is the major challenge that you say as a researcher, as a teacher, as a environmentalist. We need to look all these aspects in a holistic way, and then we need to take for the environmental sustainability. And this is, as I mentioned, this topic is mainly on the sustainable building materials and construction. So that way, this is also an integral part of this. The water management or the wastewater management is also a part of that, and we need to look into that way. And then that is very, very important. So that way, this was a general lecture. So I hope all of you enjoyed it. And if you have got any questions, I will be happy to answer the possible way. Thank you very much.
Thank you, sir. Thank you. But that was really an informative talk with various case studies. I hope all the participants have enjoyed it and benefited a lot. Now the forum is open for question and answering session. Participants can unmute and ask their queries, or may type their questions in the chat box. Since we have some questions in the chat box, so shall I read it for you, sir?
I think what is there in the chat box, am I right?
Ah, yes, chat box. It's there in the chat box. So shall I read it for you?
Yeah. So you can. Okay. So here, okay, you can read.
Okay. So the first question is of NGT has ordered to submit action plan for solution to 21 identified polluted stretches of rivers of Kerala. Collaboration of engineering colleges and water resource department of Kerala has resulted in preparation of DPRs, but the solutions proposed are to be made implemented. Is it possible to make mandatory by LGGDs? Your involvement and suggestions on this.
It is definitely possible. You see, that is what, as I mentioned, actually, we started for Alapi region. One of my colleague, Professor N.C. Narayana, started with, we are now taking what is in the summer vacation time. So we start with especially these, those who visited Alapi region, you can see that many of these canal systems that was very effectively utilized in, say, before 1950s or even till 1980s. So this canal system was very much used for various purposes, and it was Alapi town was very beautiful. But now, if you go, this everything is totally weeded, and then nothing is moved. So now, with the help of Professor Narayanan, I am also part of that. So what we are doing is we are collecting we are going to various colleges. We give training to the students, and then especially in summer time, say 2 months, these things we are utilizing the students' time, and then we are come with a plan of now treating this removing the weeds, and then also coming to that kind of solution. So as far as the NGT is concerned, of course they are the authority and they give a lot of orders, and then DPS are prepared, and then but the solution proposal has to be implemented. So that is, of course, we have a nature of implementation, everything to government, but local bodies. So that is, of course, say for example, MBITS or MA College of Engineering, Kodam is concerned. These people, all these colleges, all the students' bodies, they can come together, and then they can approach the local panchayat or local municipal corporation, and then come to an agreement. And then our own, say, though the implementation at government scale, it is of course that has a lot of red tapeism and other kind of issues are there, but we can put a lot of efforts from our sides. Actually, when I visit Kodamangalam, most of the time you can see, I think many things are happening with respect to some of the colleges there, with the help of NSS and other activities. So this is definitely possible, though government level is that is the large scale things are there, but the village level or the municipal corporation level or town level, this we can help the student community with the help of some of the teachers are coming to the forefront and take lead. This will be very much possible, and whatever is though the major projects, of course, government support, government has to be do, but then small projects, if like for example, in the place like Kodamangalam is having 7 or 8 colleges, science college, engineering college, arts college. All these people come together, that can be wonderful things. Okay, so my involvement, as I mentioned, even this was the Alapi area which I was mentioned. So that project is still going on. So more details I'll be able to share later stage, since maybe we are supposed to come on this summer there and then look into, but unfortunately due to COVID situation that is not happening. If more details are available, I'll be able to share later. Okay, that is, I hope I answered that question. So
the second question is, what about the reliability of a phytoremediation method of wastewater treatment, especially when water contains heavy metals?
This phytoremediation, that is also very effective methodology. So the reliability, that of course what kind of plants can be used. So that is with the help of, so you may have to collaborate. Especially, I understand that those who are hearing, most of your civil engineers, maybe we have to collaborate with the biology departments of the arts college or science colleges, and then we have to identify particular kind of plants, and then its reliability is very high, but you have to identify what kind of plants can utilize for these kinds of purposes, and then whether that plant itself, so if it is can be used for further composting or other kind of purpose, that also you need to study. So now most of the research is happening. So we cannot go single stream like a civil engineer. I will do only with the civil engineering aspects, but you need to collaborate with many other sections, like maybe it can be biology or zoology or mechanical engineering or electron. All those collaborative projects are needed. So that way we need to identify what kind of plants which is most suitable, and that reliability is very high. So even 80 to 90% reliability is reported in many of the published literature. So heavy metals, there is particular plants to be identified, and then that has to be gone for phytoremediation.
Okay, sir. Sir, another question is, which way wastewater treatment will be more effective? A treatment done at individual level or at community level?
So that will be the individual level. We cannot, I mean, community level. Say when we say that we have got a large flat complexes, like if you go to Cochin area, you can see large scale flat systems or large scale community level. That will obviously community level will be more effective, since that is where especially this concept of wetland, all those kinds of systems will be much suitable, since instead of single household, it is very, very difficult. Of course, if you are having some 10 cents or 20 cents or half acre of land, then definitely you don't have to say, for example, many of our household, we don't have to put any wastewater out. That wastewater will be either can be used for either other plants or kitchen waste. All those things can be used. So it is always obviously it will be community level, it will be more effective, or the say if a large scale flat systems are there, so then there can be like 100 flats or 200 flats in a society. There can be a system can be developed. Otherwise, if a housing colony, now I understand that in the places like Kerala, many ward level housing society, housing colonies are there. So those colonies also can come together and can have these kinds of community level treatment plants.
Okay, sir. So the next question is, what is the practicability of using construction wetlands for treating industrial effluent?
Industrial effluent, the problem is that as I mentioned here, very important aspect is here to identify suitable kind of plants. So industrial, if it is a highly poisonous or what kind of these things we need to study. So some kinds of not a highly poisonous kind of effluents are not there. Where definitely it is applicable, but this is especially constructive wetland is promoted for the domestic sewage, that is highly promoted, but industrial wherever highly poisonous kind of wastewater is not there, that is applicable. That is we need to study what kind of effluents are coming, and whether, say for example, if it is after primary or secondary treatment, then that what is coming, then definitely it can go to a constructive wetland.
Okay, sir. And another question is, which type of industry will be providing STP?
So which kind of, so all the industries now you see that other than in electronics industry, most of the industries, especially chemical, especially construction, all these industries, they should have STPs, but definitely you see that if you look into the history of what is happening, so many times, say for example, some of the example I can tell, like if you look into Telangana, now currently Telangana or area Andhra Pradesh. So one area was called Pattancheru. Pattancheru industrial, actually in 1970s and 80s, huge scale industrialization. I mean, whatever the politicians, what they did is that they declared some areas like as a totally free of land was given free to the industries, and then so much of tax stops were given. So advantage is that many of these industries like pharmaceutical, many chemical industries came and established this plant. And then government, the next 10 years, what has happened is the government was not, since so many tax stops and so many things were given, so they did not look into the whatever the polluter, I mean the wastewater, the waste or effluent, what is happening. So then what has happened, this industry people, if the enforcement is not there from the authorities, what happens, this they simply put their wastewater to the nearby river and also in their the groundwater or wherever it is. And then after 10 years, it was so horrific that now the people, what are the nearby areas where the people are living, entire area, their wells get so much of contaminated water that even now no water can be used in that area, especially groundwater. So that has become a major problem. So that way, we need to look into the type of industries. So that way we need to see the enforcement is also very important. So though many politicians do many kind of say tax, lot of and the incentives to the industry for industrial development, but without that is what we call it a sustainable development, sustainable industrial management, sustainable water management. So that within that we need to look into whether appropriate measures are taken and whether appropriate treatment are there. So that is what I am saying, that instead of a vertical kind of growth, we need to go step by step. Otherwise, what can happen will be very, very. So though we say that in a country like China, so we can see that they produce many things, and but if you go into the study in other way, There, what is happening is the vertical kind of development. So that vertical kind of development, the issue is that what is can happen later will be very serious issues can come. So that is why in a country like India, we need to go step by step procedure. So incrementally one to another step we need to go. So that way, industries we cannot they cannot get so much of profit without appropriate treatment of the waste, whatever they are producing. So we need to enforce that. That is what is many state governments are failing. So that is what we need to look into. So when you talk about the Coca-Cola plant, what has happened in Palakkad, all of you know. So whenever they came in the 90s, whenever it was established, everybody also industry that such a big company came and then started their plant. But when what has happened, it was not strictly implemented at that time. What is happening, whether they're taking all the water, whether they're polluting the aquifer system or the groundwater. So that is why we need to, so the industry, whatever the industries is there, so we need to, or whatever the new industries are coming, we need to look for appropriate, say wastewater, whether wastewater or air pollution or soil pollution or solid waste management is concerned. All these aspects we need to look into this. Okay, any other question?
No, sir. That's all about the questions from the chat box.
Good evening, sir. I'm Sohil Lal.
Oh, okay. Hello. Good evening.
Sir, good evening, sir. Good evening, sir. First time, actually, I heard a lot about you, but this is the first time attending one of your classes. And it was really very impressive starting from your experience from Bombay. And why not we implement many things herein? And also, as some of the chat box, they mentioned that 21 rivers, highly polluted rivers in Kerala, that DPR has been submitted. And MBC is also one among that participant for that. And also, as you mentioned about not only in Kerala, everywhere in Kerala. So, with your experience and expertise, I hope that many of the other 15 engineering colleges are also participating today. And we will be able to excel the experience which you have shared for the benefit of our future generation. And I'm really glad that you are online. And let us continue our association. Thank you so much, sir. Thank you.
Thank you very much. I think you are in a car going home, or?
Actually, I'm in between, but I was listening from your speech from the Bombay and other case studies, everything I was listening. So I just put on my video only now.
Okay. Thank you.
Really
Okay,
great,
we'll see.
really great.
Yeah. Okay.
Hello, Dr. Eldho. I'm Dr. Soli.
Oh, okay.
Hi, Eldho. That session was really wonderful, and that can be actually we can also adopt in Kerala, especially in Kodamagaram municipality. We are having Kurur Thod and all.
Yeah.
As Dr. Sajan was mentioning, MBITS is on the path to do something regarding the water resources and all.
Yes. So you are in Delhi or you are in
case studies and all.
Yeah. You are in Delhi or you are in Kodamangalam now?
Yeah, I'm Delhi only.
Okay. Yeah. Yes.
Okay, thank you very much for being in this session or in this FDP. Thank you for accepting our invitation once again.
Okay, thank you very much. Thank you.
Thank you.
Thank you, sir. Thank you, sir. And other dear participants for such an interactive session. Once again, I would like to remind the participants to fill the feedback form available in the chat box. And now I would like to invite Assistant Professor Minshida Muhammad from Jai Bharat College of Engineering and Technology to give us more feedback on this session. Minshida, please.
Good afternoon, everyone. Myself, Minshida Muhammad, faculty of Jai Bharat College of Engineering and Management Technology and alumna of MBITS. The session was very clear and effective. The subject matter was presented effectively. The session delivered the information I expected to achieve and was very well organized and systematic. I sincerely thank everyone who organized the session, and a very special thanks to Dr. T.I. Eldho, Professor, IIT Bombay. Thank you, sir. Thanks a lot.
Thank you. Thank you very much.
Once again, thank you all for the active participation, and thank you, sir, Eldho, sir. So today's all sessions are over. We'll meet again tomorrow at 9:30 a.m. for our second day of FDP. The link for Google Quiz will be shared to the WhatsApp group shortly. Kindly participate. Thank you all.
Okay, thank you. Thank you, sir.
Excuse me, sir. Somebody
Yeah.
raised a hand. Dr. K. Rajkumar. You can unmute and ask question if you have any. Dr. K. Rajkumar.
Yes.
Okay,
Yes, ma'am.
if you have any doubt or questions, you can ask now.
Yes, ma'am. I have to. I'm introduced. Dr. K. Rajkumar. I'm a professor and head of the Department of ICCS College of Engineering and Management, Thrissur. So I really impressed for your speech and presentation, sir. So whatever the important for nowadays, we have to management for waste water treatment plant and water treatment plant, everything. We know that how to, if you create the awareness for in our faculty, so not only for share about in the students. So how to awareness if you create the in the system and spread the worldwide and wide in our country.
Yeah, so that's what I was telling that we have started a scheme at Alapi, where Alapura, where these major issues are there. So that we are thinking of say further spreading to other places also. So maybe like if any engineering college is interested to collaborate with us at IIT Bombay also, we'll be happy to come together and then we can have a series of training or series of lecture programs in your college, since anyway due to this COVID issue we are not able to move to the places, but after that of course we will be happy to, especially in summertime. So we are having May, June and all those things, and then if you, especially that the faculty, if you can come with since I think most of these colleges are having NCC, NSS and these kinds of student bodies. So if we can come together and then tap them and then divert to this kind of like you take a particular kind of projects. So of course local level panchayats, so we need to have only permission of panchayats or municipal towns. So to have a project which you can plan, maybe if you put when the college starts in the month of June or July, you make a plan for by end of the year we need to achieve these things, like a small constructed wetland or small treatment plant or whatever it is in a natural way we need to conceive. And of course if you want some training or other kinds of things either from my side or my colleague's side, we can definitely give. So you can plan and then that way you can execute. So what I suggest is that especially students bodies like NSS, National Service Scheme students, that most of the colleges are having, so you can tap their potential for this. Then what I understand is that whatever our experience, as I mentioned in a place like Alapi, so that is if we put it in a proper perspective, many students are very eager to join, and then this can be a community movement. So that is what we're looking.
Sure, sir. Sure. Thank you for information, sir. We will do your best idea, sir. We will implement in our faculty members also.
Yeah.
Thank you so much.
Okay, thank you very much.
Thank you so much, sir. Today's sessions are over. Thank you so much.
Thank you.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you very much.